attending our session today. Our SEFI at Work today is entitled the Social Dimension of Engineering, Outcomes, Skills and Resistance. It's a lunchtime session, so I hope everyone gets comfortable. Feel free to have something to eat while we listen to a few amazing speakers and the work that they've done in their papers that have recently been published in EJEE. But this session has been set up by members of the SEFI Engineering Skills Special Interest Group. I want to introduce myself. So I'm Emanuela Tilley. I'm a professor of engineering education at UCL here in London, UK. And I'm also happily a board member of SEFI and also part of the skills group. So it's my pleasure to chair the session today. We have our topic today is certainly on skill sets. The two papers do talk about more than just the technical skills in engineering, and we really wanted to focus on some of the results and the outcomes that came from those papers, which are around that social dimension of the skill sets. But also we wanted to talk a little bit about some resistance, and perhaps we can have a conversation after the presenters about the resistance to helping to teach as well as get the students to develop their skill sets that are more aligned with the social dimension of skill sets. So we've got two presenters today, Dr. Una Beagon from TU Dublin with her paper, and she's the lead author on the paper with colleagues actually from across Europe. And the paper is entitled Preparing Engineering Students for the Challenges of the SDGs, What Competencies Are Required. And Dr. Cyril Picard he's currently at MIT and is joining us this morning. Thank you. And but the work was done while he was at EPFL in Switzerland, and the paper is entitled Which Professional Skills Do Students Learning Engineering Team-Based Projects? And then afterwards, we've got a Jamboard to help with that discussion, as I mentioned, to discuss the social dimension of the skill sets and the hurdles and jumps that both staff and students make when we're considering those. So I want to introduce to you now the chair of the Engineering Skills SIG for SEFI, Dr. Neil Cook from the University of Birmingham here in the UK. Neil? Hello,
thank you. So thank you everyone for connecting today, and thanks to Emanuela for organising this webinar. So as Emanuela says, I'm the chair of the Engineering Skills SIG in SEFI. This is our second webinar that we've run. We ran one in December 2021, where we looked at skills such as transdisciplinarity, communications, and some of the areas of CDIO. In this webinar, what we want to do is we want to continue talking about skills. So before we go to the speakers, I'll just quickly talk about the skills SIG and what our areas of interest are. We are quite a broad SIG in SEFI insofar as we look at many different skills. So we go look at all types of engineering skills, their relevance and important. Clearly, we're interested in those emerging skills, the skills which are underdeveloped in engineering education and we're seeing demand for, and looking at pedagogies for developing the teaching of them and the assessment and measuring and evidencing them. So that's the broad area of interest for the skills SIG. We meet online every month. If you'd like to join, if you're not a member, just get in contact with us and we can add you to the circulation list. Our current activities, they're run by different members of the SIG. We run a skills SIG survey. The last one we ran was in 2021 at the SEFI conference. We'll do that periodically, not every year, but where we're gauging the ideas of SEFI members across the community about the skills SIGs and answering some of our questions. We organise conference workshop every year at the SEFI conference as well, where we look at skills. We also just come up with ideas for SEFI too. So, for example, the SEFI podcast, European Engineering Educators, which you can find on all the platforms. That came out of discussions from our SIG and our monthly meeting. And there's also other initiatives such as the upcoming SEFI classroom. I probably announced that a bit prematurely, but we're looking at other initiatives too. So it's not just about engineering education research. It's also about bringing all practitioners into SEFI to talk about engineering skills. And there's several countries represented. You may see your country there, but if you don't, and then please feel free to join, because it's great to have so many different countries given their different perspectives from different institutions. That's a real strength of the group. People bring projects to the group, and if you bring your project to the group, we can potentially help you with enriching your data with data from our own institutions. So that's something that we're looking at in the coming years. So that's all I want to say about the Skills SIG. If you want to be a member of that, get in contact. Okay, thank you for the next slide, Emanuela. So before we actually begin the speakers, and I hand back to Emanuela to introduce them, I just want to alert you to a Jamboard that we've set up for today. The idea here is if you go to that Jamboard, you'll find that there are 2 pages to it. One is for capturing ideas about the hurdles, the barriers that we have for resistance to teaching and learning, the social dimension of skills that we're talking about today. And then the second slide, which has a small orange square on it, is the examples of how we overcome those barriers. So the idea here is just a very a Jamboard for us all to contribute to. You can throw ideas up there. If you've got a second screen while you're listening to the speaker, you can do it there, but we'll return to the Jamboard after our main session speakers today. So that's all I want to say. And the chat, July in the chat, who's the SEFI communications person, should have provided a link for you to go to that Jamboard. Okay, thanks. Back to you, Emanuela.
Great. I'm just going to stop sharing my screen and introduce our first speaker while she is setting up her slides. It's a pleasure for me to introduce Dr. Una Beagon, who is the head of civil engineering at the Technological University of Dublin. And a fellow of the Institute of Structural Engineers. Una's research in engineering education centers around using pedagogical initiatives to improve professional skills in engineering students, shaped by her previous industry experience as a consulting engineer in Ireland and abroad. Una, when you're ready, we are very pleased to hear about your most recent paper. It talks about the competencies students need to tackle SDGs.
Great, thanks very much, Emanuela. Can I check that everyone can hear me okay and see my slides? Yes, great. And thanks for that introduction. I'm not quite sure, did I send that to you? But it's very impressive. So I need to revise that, I think. Thanks very much for the invite today. My name's Una Beagon. I'm from TU Dublin, and I'm really delighted to present just briefly today on a paper that we had published in the EJEE last year. So I was asked to present really, I suppose, the outcomes of this paper called Preparing Engineering Students for the Challenges of the SDGs and What Competences Are Required, as really to start this conversation about that social dimension of engineering and how we teach it and how we react against that resistance. So just to give you a bit of background, this paper came out of an Erasmus Plus project called ASTEP 2030, which stands for Attracting Diverse Talent to the Engineering Professions of 2030. And it was certainly a team effort with colleagues from ENSTA, TU Dublin, BEST, the student group, Metropolia and Aalborg University. And I'd particularly like to thank Clara Covesi, who I think is on the call, who worked with me very closely on this paper. So I'll just give you a quick background to the project, then our research methodology and the focus groups that we held, and then I'll outline our findings and talk a very short part about a summer school that we ran as part of the project that might engage us in conversation about how we teach this social dimension. So the ASTEP project had 3 activities. The first, which was led by TU Dublin and ENSTA, was looking at the future role of engineers in society and the competences that we need. And that really formed the crux of this paper. In activity 2, that was led by Rita in Metropolia along with Universum, we undertook a really wide-ranging survey of values and motivations of young people to really identify where we could overlap those values against those skills needs to try to encourage more people to study engineering. And activity 3 was led by Aalborg University, and that was really the design of an innovative teaching activity to help us teach these skills that were identified in the first activity. So as part of that first activity, we began by undertaking a literature review looking at the role of the engineers in the future, because we thought that would help us form this idea of what skills would be needed. And then specifically, we undertook focus groups in the 4 countries with engineering academics, engineering students, and engineering employers. We asked them a couple of different questions, but the one that is the focus of this presentation was, what skills do you think engineers need in order to solve the SDGs? And really that was quite good. I think we had about 85 in total in the focus group. So we really did get a wonderful range of views. This was to remind me to thank everyone who engaged in the focus groups, because we were really able to gather a lot of data for that. So we wrote a kind of a protocol on how to run the focus group, and we all viewed the first one so that we tried to keep the same methodology in all of the 4 countries and all of the focus groups. So one of the questions we asked were, what were the competences required? And as you can see with this word cloud, a massive amount of competences. Some of the top mentions you can see there were communication, technical skills, critical thinking, so on. And I think the focus of what we're talking about today, that social dimension, things like an ethical mindset, being open-minded, and that was kind of coming through quite strongly as well as we did that. So Clara and I wanted to add, I suppose, some rigor to the findings that we had from the focus groups. So we undertook a coding exercise, which went through quite a few iterations to try to pull in all of these competences into sort of different channels. And this coding exercise eventually came up with 54 competences, which you can imagine is still quite massive. And we really coded these into 3 different areas, which I'll just talk you through now. The first one was technical skills. I think everybody is aware that we need technical skills, and we split that into some of the fundamental technical skills, but also how we apply them. And I know that's not the focus of what we're talking about today, but I think it was clear that digital skills as being important for the future came through quite strongly. The second channel that we came up with were non-technical skills. And again, we pull this into sort of 2 prongs. One being about outward facing and people orientated skills, how we engage with other people, but also inward facing skills. So the ways that we think. So things like critical thinking, systems thinking, holistic thinking, and so on. Again, a lot of these skills are coming up in a lot of the literature that we read as what's important for engineers. 2 that were surprising, I guess, for us in this sense were stress management and time management. And actually that came through quite strongly from the student focus groups. They really felt they needed help to develop those skills, which is maybe not something that we've considered in great detail before. The final channel, I guess, of competences that we came up then was something a little bit outside the box, what we called attitudes. And I think this is where the focus of this presentation and the discussion today is really engaging and interesting. So again, we split this into 2 prongs. The worldview, what is the student's worldview? You know, so they need to be aware of sustainability and the environment, but they've got to be lifelong learners, have social responsibility, and so on. And the other was, again, much more inward facing. It was about their character and ethical orientation. And you'll see here agility and adaptability. But again, some of the key ones that came up for us were empathy, emotional intelligence, perseverance and grit, ethical conscious, and personal engagement. So again, a focus on those kind of social aspect of what we need for the future. So that outcome is really the crux of the paper in EJEE, if anybody's interested in going into that in detail. But I just wanted to finish off really, I'm doing great for time actually, so I take a few more minutes. I wanted to finish off just explaining the end of the project. So activity 3 was to run a summer school. And this was led by Aalborg, and it ended up being online, although we had intended that it would be in person because this was during COVID. But we kind of picked this theme of future orientated thinking because we thought that pulled in a lot of those skills that we mentioned before in terms of adaptability, creativity, time management, and kind of world awareness and worldview. And the summer school was run over 5 days, and we picked kind of workshops in futures literacy, scenario thinking, backcasting, road mapping, and I'm going to talk to you about designing a monster and show and tell in a moment. But we were really setting up the students with workshops to get them to practice these types ways of thinking and expose them to futures literacy and what the future is going to be like. And one of the things we were keen to do was to really engage their creative spirit. So designing a monster was really the output of the summer school. And we called it a monster because we didn't want to say it's a presentation or it's an idea, or we just wanted to give it a really engaging creative word to let them think about what they wanted. And then our show and tell session was really where they presented their outputs. And the scenario that we gave them was to look at the future of engineering education. So they had to do this backcasting and road mapping exercise and then come up with designing a monster and show us in the show and tell. So I'm just going to finish off with a short video of one of the monsters. We were really surprised at what the students came up with. Some of them came up with a sketch where they videoed themselves on a Teams meeting, having a conversation about the weekend, and one of them had a dream about this future of engineering education where there were no lectures, and it was really fantastic. Others came up with kind of a comic strip cartoon. It was really impressive. But I just want to show you this one. And these guys came up with a podcast they're discussing this new thing called Vision Water, which is a drink that you drink that has chemicals in it or whatever, vitamins or whatever, that are specifically designed to help people become engineers and become good engineers. So I'm just going to show you this. It's less than a minute, and hopefully you can hear this. Please stop me if you can't.
Are you feeling dull, uninspired, and also just gosh darn thirsty? Then Vision Water is a drink for you. It's no ordinary drink. It's the ultimate answer to all engineering students' problems. After having Vision Water, you'll feel refreshed and ready to conquer the engineering industry. This drink was created by the top scientists to combat all difficulties students face when starting their educational careers. One sip will give you access to attain the skills and positive morale engineers require. Side effects include creativity, sharpened technical knowledge, motivation, enthusiasm, critical thinking skills, and clear problem solving. Order now through our website, www.visionwater.com.
So I just really wanted to show you that, to show that in that particular scenario, the students were really creative in coming up with this way of developing these skills. And it got me thinking about two things, one being that resistance that we're going to talk about later, but also the ways that we can engage or encourage students to develop these skills within our existing module selection. So I just want to finish off really by acknowledging our EU funding for the A-STEP project. And also I know we're going to talk later about some ways that we can encourage this. And I suppose I had 3 questions coming out of this project. The first is we could probably have a conversation about, is it the responsibility of HEIs to teach all of those skills? I mean, can we teach ethical conscience? Can we teach perseverance and curiosity? Secondly, how do we make room? So, we read in all the literature that we already have an overcrowded curriculum. So how are we going to make room for opportunities for students to develop these skills? And then I guess the third one is, how do we convince our colleagues about the importance of non-technical skills? And I'm just going to finish by one, or kind of highlighting 2 things, I suppose. This summer school really engaged me significantly, and I'm currently working on another project which is funded by the Irish EJEE called Profess 12. And we've just run a summer school along these lines with students from Northern Ireland and Ireland to try to look at intercultural skills in the 2 jurisdictions, because intercultural skills is another really key topic. And I have lots of learnings from that. That was just 2 weeks ago. And I'm also working on a project with my colleague Lynn, who I think is on the call with KU Leuven, called Train Eng PDP. And that's looking at putting interventions in the classroom to encourage students to develop their lifelong learning skills. So I think, again, that idea of running interventions and learning about best practice in that way will be useful to do it. The interventions are within the curriculum. The summer school is external to the curriculum. And I think that's what we're going to have to look at later on. So that completes my presentation. Thank you very much. I'll hand back to you, Manuela.
Thank you, Una. That was great. It was a really great way to kick us off, particularly with those questions. Interestingly, that you came away with from your project that are very relevant to our conversation today. So thank you very much. I'm going to introduce us to our next speaker before we open the floor to questions and more of a discussion. So Dr. Cyril Picard, Cyril, if you'd like to connect and show your slides, that's absolutely fine while I introduce you. He is a Swiss National Science Foundation postdoc mobility fellow within the Department of Mechanical Engineering at MIT in Cambridge, Massachusetts. I can't even say that right. Cyril successfully defended his thesis entitled Automated Design, A Journey Across Modeling, Optimization, and Education in 2021 as part of the Laboratory for Applied Mechanical Design at École Polytechnique Fédérale de Lausanne. So that's EPFL in Lausanne, Switzerland. And he's going to present his paper that he's the lead author on to us now. Cyril, I leave the floor to you.
Thank you, Emanuela, for this kind introduction. So I am Cyril Picard, and I want also to highlight that this is a shared work with Cécile Ardebold. I saw she is on the call. She's also a co-lead author on this work together with Roland Tormet and my former PhD advisor, Jörg Schiffmann. And I'm going to continue on this discussion of non-technical skills that Una already started. And we're going to look a bit more into the practicality of how do we actually get students to learn professional skills. And we'll be looking specifically at the team-based project setting. I just want to highlight quickly what my background is, because I think it's kind of relevant to why all these skills are interesting. So I'm a mechanical engineer by training. I have a PhD from EPFL, also on a very technical, most of my thesis is very technical question. And I'm now doing a postdoc at MIT looking at the use of artificial intelligence for engineering design. But I kind of see this from my perspective and my technical work, I see the need for these professional skills. And so I have kind of three pillars of my research. Is I see machine intelligence as a tool for engineers, and I also value evidence-based education. And so this is one of these contributions in that direction. Heading off towards motivation, I think most of us agree that we live in a very fast-changing world, and some skills that are important today may not be important tomorrow. And so this is a bit provocative comic by Britt Spencer, suggesting that coding skills will be part of museums by 2050. Now that comic was actually from 2018, and with the recent development of in the world, and particularly in artificial intelligence, I think most people kind of start to think that this may be a realistic scenario and not that much of a provocation anymore. Nonetheless, I mean, for us, the question is, how can we best support our student in this fast-changing world? And so this is why we were interested in promoting professional skills. And of course, these are kind of, I mean, it's a very generic term, and we're thinking about things like time management, planning, risk assessment, communication, and so on. So from my, technical issue, from my perspective, I'm a AI researcher in that sense. So I obviously asked ChatGPT for help on this presentation. And I was actually surprised how good ChatGPT was at these topics, and maybe we should use it to convince our colleagues. So I asked ChatGPT, what are professional skills? And out of the very long answer that ChatGPT typically gives, there was this sentence. I think it's pretty straightforward. So professional skills are highly valued by employers as they demonstrate a candidate's ability to adapt, collaborate, think critically, and communicate effectively, regardless of the specific job requirement. And I think this is really, I mean, given this definition, professional skills are exactly what we need to teach our students to work in this continuing changing professional life. And actually most certification boards in the EU, but also in the US, agree that this is indeed a skill that should be taught in our engineering engineering curriculum. And by the way, so I didn't cheat anything. This is really the answer of ChatGPT to this very simple question. Now, how do we get to learn those skills? And at the different institutions where I was, I often hear people say projects are great for students to develop their professional skills. But it's often pretty fuzzy, and it's also implied that they learn just because the students are part of the project. They do the project, they practice the project, and they learn. But there's no discussion about courses on these topics or assessment regarding these skills. So it's kind of, people believe that they magically learn skills. Some people believe. Then there's the other extreme is, and there is actually a setting where there is evidence, or at least in 2019, there was evidence that that these settings were promoting the learning of professional skills, and that is project-based learning. So curricula, which are completely reorganized around project-based learning, have shown that they were actually better at promoting professional skills. But this is really the other extreme, and it is very time-consuming to set up, and requires basically the whole faculty, the whole department, and the whole department to agree and work towards that goal. So this is very expensive to do. So let's go back at how we can learn this. And again, I've asked ChatGPT how we can learn this, and it suggested 8 different contexts and approaches where students can learn. And I just want to highlight out of these 8 that there are internships and extracurricular activity, which have actually become very popular and are being integrated into curriculum, I think, across Europe. And as well as group project and reflective practices, which is a bit what I will be talking about today. So our work and our paper basically comes down to providing some answers to these 3 questions. How can we assess those skills at scale? Which professional skills do students learn from projects? And are there characteristics that support their learning better? So for the how, we actually used a questionnaire called the Interprofessional Project Management Questionnaire that was created by Roland Torme and Marc Laperouza. It's also an EJEE publication. It came out after our publication, but it's actually prior work to ours. And it's basically a 24-item self-efficacy belief assessment questionnaire with where each question is scaled on a 5-point Likert scale from strongly disagree to strongly agree. And typical questions are, I'm good at defining a clear work plan early in a project. I'm good at trying to understand the perspective of other team members. And they're grouped into 5 domains: planning, risk assessment, communication, ethical sensitivity, and interprofessional competence. And I think it actually overlaps a bit with some of the skills that Una has identified in her work. So if you want to use the Interprofessional Project Management Questionnaire, or short IPMQ, as I'll call it later, the questions are available in our publication, as well as, I guess, in Roland Torme's later publication as well. And so feel free to use it if you have a setting where that could be useful. Now, how did we look at how did we use it? We basically we have a very simple pre-post survey design. And we looked at 3 different classes, 2 bachelor courses where they had what we call in-course projects. So these are smaller projects that are run typically in parallel to a traditional course. Students will, in that context, work 4 weeks on a project instead of doing exercises. And here, so the design is basically, we had them take the pre-questionnaire before the project started and after the project was ended. And as we see, there were so in the bachelor course, we had 306 students total, but only 168 participated in the pre and 47 participated in the post questionnaire. And then we looked at a second type of course, which was a master course. That's a mechanical engineering capstone design project. So this is a full semester of project where students are asked to come up with design something. Actually don't remember. Oh no, I know what was the. So they here in that case they had to design a gearbox for heating and ventilation application in a car. So very specific topic, but they had to come up with ideas and make their own design. Here we're talking about of course, a much smaller class, 33 students, but they had a series of reports to give. Here, since we couldn't do the before the course, we did it in the beginning, and the post was done after. And here we have a very high response rate of 32 students and 29 in the pre and post, respectively. We also asked 40 experienced professionals from our with the industry that we were collaborating with to fill out the questionnaire, so that we kind of know and we kind of have a baseline. Okay, so that's for the broad introduction. And now if we jump into the results, basically the results are shown in 3 graphs like this, where we either compare across population or within population, the pre and post. So since they all look the same, I'm just going to give you a quick intro. On the right side, you have the total score, the total IPMQ score, and on the left side, you have basically the 5 domains that are being split up. And then we of course perform statistical testing, and if there are any significance level, they will be reported at the top with the star notation. So what we see across, so if we look at our initial, so pre-test and experienced professional, and we try to kind of see where we're standing as a starting point, we see that there is a clear gap between bachelor student and professional and master student and professional on some factors, especially between bachelor student and professionals. And we see only a few difference between bachelor and master students, and some factors which have no difference at all. Again, we're not drawing much conclusion from this, except that we want to see, okay, where do we start? And so obviously there seemed that the student can somehow, they can progress towards professionals. We do also not think that professionals have all the skills that they may need. Now, more interesting is to look at the different settings of projects. So if we looked at what happened in the in-course project, so bachelor students, here we see that there is mostly not much happening. So there is no global gain. So if we look at the total IPMQ score, there is no gain on this side. There are 2 factors where there are small gains, so communication and interprofessional competence. And so on the line below, you have the Cohen's d, so the effect size. In both cases, it's below 0.4, which is kind of the metric to decide whether it's a meaningful educational intervention. So not much happening. If we look at capstone projects and the difference in pre-post results for those, the picture is much different, and we can basically distinguish 2 effects. First is we see a pretty strong, we see a strong gain in the total IPMQ score. So it's kind of a large and broad gain of these skills by students with an effect size greater than 0.4. And then there are 2 factors for which we also have a strong effect size, and these are planning and risk management. And what is good about that is that this particular capstone project course was organized around these 2 skills. So students received courses and had to provide, they were assessed on these skills in their reports. And this is where we see the greatest learning, which was great, great news for us, right? So I was part of the teaching team too. So that was our kind of success on that part. Okay, so if we summarize this very briefly, of course, not all projects are created equal. We have on one side, we have in-course project, and here I'm just summarizing typical setting. That means there are 30 to 50 students per teaching assistant. The students meet with a TA on demand, so there's no rigid structure. They meet whenever they want, and they meet if they want. What is the consequence of that is limited effect, limited learning. And it is actually especially limited since we also asked qualitatively to students afterwards how many of these projects they did during the semester, and they answered that they did at least 3 others. I mean, at least two others, so 3 in total. And so despite the quantity of these projects, there wasn't much learning that we could measure. The slight nuance is that in this qualitative feedback, all students claimed that they learned these skills. So it's also possible that there was some learning that was not strong enough to be visible in their self-efficacy beliefs. Now, the capstone project on the other side is basically 8 students per teaching assistant, weekly meetings, class and assessment on project management and risk assessment. And the consequence of that is broad learning, strong gains in these 2 domains. And this is a simple course that can be implemented in any curriculum without having to change everything around it. If you want to go further, we see that there was some resistance into participation by the bachelor students. I mean, we see 15% answer rate in the post questionnaire. It's a challenge to motivate large classes. We don't know if it was age, lack of interest. I mean, for bachelor students, professional life seems probably very far away, but also we don't know it was a lack of relation towards the objectives and requirements of the course. The course was not about project management and professional skills. So there was an implicit relation between course and these objectives. For the more psychometric people, there's of course the question that is not answered, whether there's a correlation between a self-efficacy measure and a kind of absolute measure. We know that this is the case for disciplinary skill, but we don't know if this is the case for professional skills. And although it can be used as a self-reflective type tool, we don't know if the IPMQ, and we do not have results regarding that, if this can be used in that setting. Key messages from my side: professional skills are important for engineers and scientists. I mean, I'm pretty sure you're all convinced about that. I don't need to convince you. But we have self-assessment tools, and they can be used to assess these learnings, and they can be used at scale. So we did this with 350 students. It was perfectly manageable. Expecting students to learn just through practice is unrealistic, but having explicit consideration for professional skills can support effective learning. So basically, my key takeaway maybe is simple changes can be implemented and they're effective. Thank you very much for your attention.
Thank you, Cyril. I've made a couple of how we it is learning. I did also notice the impact of facilitation, perhaps, on terms of the students. I wonder, you said in the in-course project there were 20 to 30 students per TA as opposed to 8 students per TA. And I do wonder whether or not that facilitation and the validation and the role of the staff member also helps with making it explicit to students in that time that these things are important. Those are my takeaways, but thank you so much. That was really